is, well, I'm Matthew Revell, as it says up there. I work out the London office as a developer advocate for Couchbase. So the first thing I need to do is apologize for the BuzzFeed-style headline. I just wanted to make everyone really excited about being here by putting a number in the title. Okay, so the subtitle is, this is a talk about answering questions using Couchbase. So again, not much detail. Data comes in lots of different shapes and sizes. And this here is probably one of the earliest examples that we have of human writing. This is Sumerian script from the Mesopotamian civilization, which is or was in present-day southern Iraq. And this, you know, we've been able to translate this stuff to an extent, and we're kind of, our current understanding is that, you know, generally this sort of stuff was the sorts of things we write about, you know. It was nothing that would surprise us. So there are letters, there are ledgers, you know, this could be a ledger of someone's stock of wheat or their number of sheep, or, you know, like looks a bit like an animal down there. So it's pictographic, you know, but it's a form of data. And I was quite curious to know what this was about, so I fed it into Google Translate, and it does turn out that it is about agricultural stuff. Anyway, so then, you know, we moved on into other forms of data. So this is a Jacquard loom, the first example of a set of programmable instructions that could be given to multiple machines and result in exactly the same procedure of tasks each time. It's only about 1960, with the release of the Sabre system, a joint effort between IBM and American Airlines to improve airline bookings, that we see the first example of a commercial database. And even then, that wasn't a relational database. It was what we would probably think of today as a graph-style database. Interestingly enough, Sabre are now a customer of Couchbase. Then in 1970, this guy puts out a paper. This is E.F. Codd. He worked at IBM, and he put out a paper that described the relational model for databases. Even at that point, SQL didn't exist. It was only a couple of years later that he and some colleagues came up with SQL as a query language. So, you know, relational, my whole point of showing you these slides is just to say that relational isn't the norm. Relational is just what we've been doing for the past 20 years by default. You know, it was only 1979 that Oracle came out with the first version of their relational database, and it's only about 1995 that MySQL, you know, had its first release. So, although we kind of think of it as the default now, we think very much in terms of normalized tables, in terms of, you know, rows and columns whenever we think about our data. That's not the default. So what are those three things that I wanted to mention? Well, the first is that you need to think of questions, not answers. The next is, it's soft schema is what you need to be thinking about in terms of shaping your data, not no schema. And the last is key design is really important. So I'll go into those, what they actually mean, after some Couchbase basics. So I'm guessing most people here are aware of the basics of Couchbase already, but just very quickly, because it's pertinent to data modeling. It's a key value store, so you can bung anything you like in it, with special support for JSON documents. It's got caching, so, you know, it's fairly, like, speed of, you don't need to, what I'm trying to say is you don't need to necessarily model your data in such a way to get around speed problems, because Couchbase is fast. It's a distributed database, but it's consistent rather than, it's a CP system, for those of you into the CAP theorem. So it's consistent, strongly consistent within a cluster. And you can generate secondary indexes using Nickel soon, do interesting queries with Nickel, or you can do just standard kind of secondary index querying with views. Okay, so questions, not answers. What do I mean by that? Because surely the only thing we really want from our database in any circumstance is a bunch of answers, you know. Well, relational databases are kind of optimized for situations where we don't necessarily know what questions we want to ask. Well, kinda. So you know, you sit down and you're working out your new application, and most people, I think, will start to think in terms of what tables they need, and what joins they're going to have in those, and so on. And basically, you start modeling your data in such a way that the data model itself often leads your application design in a way, but also your data, because it's normalized and because it's very well, very easy to query. Your data is basically set up in such a way that you can ask any question you want of it. So it's kind of an answer store, Whereas with a document database, we're looking at things slightly differently. So let's look at how we would model a very simple stock system in Couchbase. So we have Couchbase branded swag, USB sticks and t-shirts and things like that. So we want to track them. So, very simple example here. We've got a products table, a customers table, an orders table, and then an orders details table. So you can track exactly which items are going into an order. So you can see, we've got various joins here. Lots of complexity for a very, very simple data model, I guess. Oh yeah, I made them flash. So a document database is more like a library in some ways, I think. So in a library, we have lots and lots of answers in lots and lots of different documents. But sometimes you'll find the same answer in different documents, the same bit of data in different books. So you might have two books that both tell you how to build a house. One might be a book on architecture, another one might be a book on, just kind of basic survival skills, I guess. One might be telling you how to build a mud hut, but the other might be telling you how to, the principles of building a great big concrete palace sort of thing. So the point being that in a document database, you need to think more when you're modeling your data about what questions you're going to ask. In the relational world, we just put the data in there in a form that seems to be, that reduces repetition to basically nothing, and in a form that we can query in any way we want to. In a document database, we need to think more about, how am I going to query this data? What questions, what things am I going to need to ask of this data as I go along? So you need to think up front about the access patterns that you're going to have when you're working with this data in a document database. So if we go now to have a look at that order that I showed you with the tables, this is how it might look in a very heavily denormalized document database example. So we've basically got the entire details of the order, including things like the description of the item are in there, in that one document. And this brings me on to aggregate-oriented databases. Or we could think of them as answer-oriented databases. So Martin Fowler is a consultant at ThoughtWorks, and he's written a lot about NoSQL databases. And one thing that he says is that when we're dealing with document databases or key value stores, we're dealing in aggregates of data. So here's an order form, a real world. Imagine that's a paper order form. In the relational model, we split that chunk of data that we access and think of together into multiple rows in several different tables. So in an aggregate database instead, what we're doing is we're storing together the data that we access together. So instead of splitting that out into multiple rows, we store it as a chunk. We store it as a document in the same chunk that it comes when we need to work with it. So why optimize for the questions that we're going to ask? Why not have this kind of actual, beautifully elegant, normalized data set that we get with a relational database? Well, basically, we're optimizing for different things these days. Back when EFCOD came out with the relational model, memory was really expensive. Disk was very expensive, or any kind of storage. Now, disk and memory are things that we need to think about in terms of cost base. But really, what we're optimizing for now are concurrency of access, scalability, and unpredictable scale at that. If we put a mobile app up and it gets a link from, it's featured in one of the app stores, we can't predict when that's going to happen necessarily, but we have to respond to it. Success is something we shouldn't be afraid of, and so we need a database that's going to scale. And so we have to work with basically a database model that scales well as well. So storing data together in the aggregate model, in the document model, is efficient because we're doing basically one disk seek, or with Couchbase, normally you're just hitting the RAM cache in order to get that data back. And then to put it in there, you're doing one disk operation, or maybe just hitting the RAM cache. And importantly for that kind of scale story, data aggregates are easy to distribute around multiple computers because you've basically got this one chunk of data that you access at the same time. So you're not going out to multiple machines to pull in one particular result query to build an order form, for example. So, to summarize, we basically take this 4 tables with the multiple joins and the many disk seeks and turn it into something like that, which is easy to distribute, which is fast to access for reads and writes, and which is heavily denormalized. So that's why we need to think more about the questions that we're asking up front, because that denormalization that we see here, that enables us to have a set of aggregates so we can distribute around a cluster, is basically what we're doing is we're pre-canning the answers that we're going to need from the database. So up front, we need to think, what are these questions that we're going to answer in our application? Because when we store the data, we need to come and then make multiple copies of the data, potentially in different contexts around the data set, in order to answer those questions that we're going to be asking. So yeah, what questions do we ask then? Well, that really varies from application to application. How long is a piece of string is what my slide is trying to say. The questions you ask are really down to your use case and the application that you're writing. So I'm not going to spend any more time on that, but there is a really good question that we need to ask about building these aggregate types of databases. Is how much do you embed? How much do you denormalize? How much do you store multiple copies of data around different documents? And how often do you refer out to other documents? It depends. So whenever you read or hear about NoSQL, it's often in the context of denormalization. The idea that we shouldn't be aiming to have a neatly normalized data set because the world is messier than that, and it's easier to distribute these denormalized forms. But actually, in the Couchbase world, when you're working with Couchbase, generally you are, to some extent, normalizing your data. At the very least, you're referring to data that's stored in other places. So it's not as black and white as saying that a document database like Couchbase is a strictly denormalized database. So you need to think about, though, how much you want to refer to other things, basically do this kind of normalization within a database like Couchbase. So you should embed data. So you should have those really denormalized documents when speed of access is your main concern. So, okay, Couchbase is fast, but if you're doing 5 queries, it's going to be slightly slower than doing just the one. You would embed data when your number of reads outnumbers the number of writes that you're doing. So why is that important? Well, the thing is, when you're writing into multiple documents, the same data into multiple documents, there's a very slight chance that something at the application level might go wrong, and you can have some inconsistency drift in. Because imagine you had a user profile, and you update that user profile, and accordingly, you need to update, say, all of the live orders that's going to go out to that person, so that their address now reflects what's in the new user profile data. Well, if you have to update all of those and then the application server making those updates to those documents fails, you might find that you have one particular live order document that now has the old address and all the others have the new one. So you could have some slight chance of inconsistency drifting in there. So if you have many, many, many more reads than writes, then that's kind of fine, because you're basically optimizing for your normal case, your usual case, which is reading the data. So you want it as fast as possible for those reads. So then embedding the data into multiple documents is the way to go, because that gives you that fastness of access. But if your writes outnumber your reads, you're making many, many more updates, then you probably want to just make that update in one place. So in that case, you wouldn't want to embed that data in multiple documents. You'd put the data into one document and then refer to it from the documents where you need it. So basically, yeah, you embed when you need the speed, which again, like I say, isn't that much of an issue with Couchbase because it being largely cache-based. And also where you're comfortable with the risk that some of your elements, the repeated elements of that data might drift out of sync with each other if there's a problem on the application side. So when do you refer? Well, actually, I would say that by default, you would probably usually refer to data in Couchbase. So I'll show you an example in a moment, but basically you would refer when query flexibility is important. So having data embedded in lots of documents makes it harder to do queries on that data, because you're finding it within another data structure, and also you lose some of the context. So it's harder to say, give me this person's address if it's only ever stored in order files. But if you've got it as an actual document of their address, then you can always query those address type documents. It's also important, like I say, you'd refer to data when consistency is the priority, where you really need to make sure that when you update that particular bit of data, then it remains it's updated in all the contexts in which you'd find that data, just as we would in the relational world, and we'd expect that there. And also, I would say refer to data when that data has a large growth potential. So, for example, if you were writing an instant messaging client and you were storing the conversations in a document database like Couchbase, then you would probably want to you wouldn't want to embed the conversation in the profile of the two people who are having the conversation, because it would have unbounded growth. That conversation could go on for many, many years and turn into potentially megabytes of text. So let's have a look at an example of embedded versus referred. So here's our embedded document here, as I showed you earlier. Everything about the order is stored in there. There's my address, there's the products that I've ordered, there's the status. So like I say, that's the denormalized form. That's one document that gives us all the data that we need about that particular order. The alternative is to split it up into different documents that give us chunks of the data, just like we would pretty much in a relational database. So here I have the order details. Notice that I don't need a separate order details table, because it's fine just to embed that as an array inside. Well, in this case, it's not an array because it's one product, but I could have that as an embedded array inside the JSON document. But so I've got my order details. I've got a single customer record, so I don't need to embed that. I don't need to worry that if I update something there, I've got to then update it in every single instance of where my details exist. And then there's the product there. So what I can do here is the item that I've ordered is product 1. So I look up product 1, and the customer is customer 40. So I can look up customer 40. But I thought we were here to denormalize. I thought that was the whole point of document databases and the NoSQL movement. Well, yeah, kinda. But the thing is that Couchbase is the database that you can actually use. You don't have to think, oh, hang on a minute, that's gonna add some lag, and oh well, no, I don't want to be hitting the database too much because then I'll have to add another database server and worry about a sharding scheme and about replication and so on. Well, no, Couchbase is just the database that you can just hit whenever you want to, and doing those 3 queries or those 3 gets is going to probably take 1.5 milliseconds. That's kind of not enough time to do the disk seeks on the SQL query that you need to write to get that out of a relational database. So denormalization can be useful. It can make things. It can make your data set, I guess, kind of messy, but it can make your querying simple because you're doing one get. But when referring to other documents is so cheap, then you might as well take the benefit of having that greater data consistency. And yeah, they're cheap, they're quick in Couchbase, so there's not really much of a harm in doing it. The only thing I would say is that the work of pinning that stuff together is on the application level rather than writing, at this stage, a simple SQL query. Now, obviously, when Nickel is in production, things will change, and this talk will change. Okay, so the last thing is soft schema, not no schema. So another, along with denormalization, another totem of the NoSQL movement is the idea that it's schema-free. Well, yeah, kinda, but really, whenever you're writing an application, you have some kind of schema for your data, unless you're taking in completely raw data from somewhere. Oh, well, I assure you that my slides are highly interesting for the rest of the talk. Okay, well, anyway, so okay, not to worry. So yeah, so even though schema-free is the phrase that we bandy around a lot, it's Alfie, Lily, and George, right? Not members of the Beatles. Okay, so soft schema, not no schema is what I'm trying to say. So you as an application developer now need to start thinking about the schema probably far more than you did before, because before you might hand it off to a DBA, or it might have been one thing that you thought about when you were designing your application, and then maybe later on, you do a schema change and you need to think about it again. But generally, as an application developer, you're not thinking all that often about the schema of your data. But you will have a schema for the data that you're working with in Couchbase, because data has shape, and for it to be useful to us, we need to know how we're going to access it, how it's going to look like. So, Couchbase doesn't enforce the schema, but you do now. You start to think about it. But the thing is, though, it's less painful in a sense, because migrations of your schema are now okay. They're not a thing where you have to take the entire database read-only just to add another bit of data to your data model. So let's have a quick look. We've got a user class in Java there. So all of that's really easy to represent in both relational and a document model. But then we add an array of orders that the person's made. How do you represent that in a relational database? Well, there are a few options. You could do joins. You could serialize the array to text, but then you break in the normalization forms, and also you're making it harder to query. Or you could use a JSON document and a document database, and there you go. There we've got an array of orders, and that's fine. So the thing is, though, talking about schema and schema changes, is when we now want to come to add something to our schema, we want to add the products that the person's viewed, then we add it to our user class, no problem. In a relational database, like I say, we'd have some pain in making that schema migration. Whereas in Couchbase, we just add it to the JSON document and we save it out, and that's fine. So the pain, I guess, comes in that you now need to track the schema version that you're using in your document, and every time you come across a document that's using the old schema version, you need some application layer code that will make an update to that document to bring into the new schema version. The good news is you can do that document by document. You don't have to do it, like I say, an entire data set at a time. You're not locking out writes while the migration happens. It's just, it happens as and when it needs to. And the good thing is that because you're doing it to the documents that you're reading, your important hot data set will get updated first. And then you can have a cron job in the background that runs through slowly and updates the older stuff. Okay, I've only got a few minutes left. The key is the key. So key design is as important as document design. Getting your keys right is going to be the key to having a successful data model in a document database like Couchbase. So there are broadly 3 types of key. Human readable, so something like your email address if it's the key for your user profile. Computer generated, so a UUID or some kind of random other thing. Or compound, where we put together both of them. So let's have a look at our user. So that's the JSON document resulting from that user class. Key it by my email address. Well, that's great. That's really useful because I'll log into the system with my email address. We always know what the email address is because I have to log in with it. So we can do a simple get query with Couchbase and we get my document back. Brilliant. Okay, what happens when I change my email address? Well, that's a bit of a pain then, isn't it? So what do? We create a new document, copy that over, and then destroy the other one. Well, that seems inelegant. So what about we key it with some kind of random computer-generated thing, and then we just put my email address in the document. That solved our problem because we can put some kind of constraint in that makes that unique, and it's not related to that, so I can always change my email address. But how do we ever find that again? Because I'm not going to want to log in as 1001. It's not my. I don't know if you've ever seen Reddit usernames where someone's just typed in a random load of stuff. How do they ever remember that? I can't remember 1001, but I probably can. But anyway, so what we do is we have what we call a. It seems to be every time I step on this bit here. So we have what we call the counter lookup pattern. I'll just stand still. So. In Couchbase, we have atomic counters, so you can hit the key with an increment or a decrement request, and it'll give you back the counter minus or with whatever number you supplied. So we have a counter key here, right? And then we send an increment, and that gives us back a number. And then what we do is we create our user profile using that number as the key, and there's our JSON document. But we create another lookup document, which is keyed by my email address. And the value is simply a string with the number we got back there. So what I can do is do a get with my email address as the key. We'll get back 1001, and then I do a get 1001, and that gives me back the JSON document with my user profile. Like I say, Couchbase is the database you can use. You can hit Couchbase a couple of times, and it's only going to take microseconds. Hit it a couple of times, maybe it'll take a millisecond, as long as it's coming out of the cache. Obviously, if it's a cache miss, then it's a little bit slower, but you size your RAM according to your working set. So that's one way of dealing with that problem. And that brings us into the whole world of lookup documents. So you can have multiple documents where we use my Netflix ID, and then that just has that value. So, we look at an alternative email address for me. That gives us the value of which is the key name of the JSON document with my user profile. So we can have all sorts of different things. You can basically have all these manual secondary indexes where you're keying on some data that is human derived. That's something that you know about the person that they might supply. And then you can get back as the value, the actual key for the document you're looking for. So you might notice here some things like this. So it's very common in key naming in the Couchbase world to put some kind of semantics into the key name itself to describe what it is you're looking for. Because in the Couchbase world, buckets are resource allocation more than they are namespaces. So we namespace the keys. Okay, compound keys, very, very briefly. Compound keys are a continuation of what I just showed you with the semantics in the key name. So let's have a look at this. Here, yep, that tells us it's a user document. And then we could add onto that key name, products viewed, and that will always give us back a document that shows us what products that person has viewed. So again, this is like the embedded versus referred discussion. But if we're erring towards referring, 10 minutes. Oh, right, okay, I'll slow down. If we're erring towards referring, then what we can do is we can create multiple documents where we have additional information about this person, and we use the key name, a predictable key name, so that we can always find out more about that person in this case. But in the case of going back to an instant messenger client, it could be that you build up the key name out of the two participants and then maybe a timestamp or something like that, for a particular day's worth of conversation between those two people. And there are lots of different ways that you can use your key naming to build up to make your querying of your data more elegant, I guess. And then, so we've got products list here, and then we could do another lookup on P8, which we know in our world, in our little application, P means it's a product, and then that gives us back the product that the person's looked at. Okay. So, we have, as I mentioned briefly earlier, we have two different ways of, right now, one in production, one in beta, of creating automatic secondary indexes, additional indexes, or queries on data you store in Couchbase. Views are great. They're really useful for ad hoc querying, for queries that you didn't anticipate when you wrote the data into the database, or for doing more complex things that you perhaps wouldn't necessarily use lookup documents for. But you shouldn't use them. You shouldn't use queries as a crutch for bad data modeling. There are various reasons. One being that there is a cost to pay in terms of CPU time and a slight lag in processing the indexes created by views that you have to pay when you're working with views. So you make an update to a document, it will be a short period of time later that the view-derived index is updated with that change that you've made. So they're eventually consistent, basically. Whereas the manual indexes that we were just looking at, the manual lookup documents are just normal documents in Couchbase. So they have all the strong consistency and all the great speed and the lack of CPU impact that any other get or set has in the Couchbase world. Yeah, so manual indexes should always be your first port of call. I really rattled through them because I wanted to make my time, and I think I've underestimated how much time I had. So, ta-da! So any questions?
Can you go over the manual index part again?
Sure.
Would you repeat the question?
Sorry, I was asked if we could look at the manual indexes again. So basically, the idea is that you use some document in Couchbase that is keyed by the thing you're looking for. So if you were doing a phone book, it could be the person's phone number. And then the value isn't the document that you're looking for. The value is the key name of the document that you're looking for. So you're doing two gets, basically. And the reason for that is just, the person might change their phone number, but all of their other details remain the same. So it allows you to have some kind of flexibility over the data that you're storing. The other thing to say is as well, using a counter is a really good way of generating the random, well, as good as random number that you're going to use as the key name for the main document, because it gives you a couple other things like it tells you very simply how many user profiles, for example, you've ever created in the system. So you could then do a multi-get of all of the different people that you've got, or the last 5, or something like that. So that gives you some other advantages as well. But yeah, it's not hugely complex really. It's basically you have a document with something that you care about as the name, and then the value is the key of the document that you are trying to get to. So it's kind of a couple of hops to get to the document that you want. Any other questions?
You said the automatic indexes are eventually consistent, so I won't see the data right away. Is that the case with manual indexes as well?
No, because they're just normal document, yeah. So you, as soon as you write them, you've got all the benefits of a strongly consistent Couchbase document. Whereas the indexes created by views are updated, well, you can update them at query time if you want to. Obviously, there's a bit of a price to pay because you're running the query again, so your query will take longer. But they're updated automatically every 5,000 queries or every 5 seconds, I think, by default. So they're kind of a little bit out of sync. Yeah. Sorry, Andrew.
Your image here somewhat implies that 1001 is actually a numeric key and not a string key. Is that the case? Or is it always referenced in the document as the U:1001? Is it a string?
So this U is convention that we would know about, that we've set up in our application.
So it is a string.
Yeah, yeah. So you don't, and strings are faster in Couchbase than JSON documents, very slightly.
Because in my views, I sometimes have natural numbers as my keys.
Okay, right. Sorry.
Yeah, you mentioned about embed versus refer data model, right?
Yeah.
So with respect to the refer data model, where you have multiple documents, right? And how do you, is there something like you could define relationships just like we do in relational database, or
no,
it's the primary index and the secondary index?
So it's basically whatever you're using as the key on the document you're referring to, you would embed that somewhere in the JSON document. So you would, you might have, I don't know, address, and then the value would be the key of the address document. So yeah, so there's no formal way of doing it. This is just a practice you can use. Yeah.
So it sounds like the composition of the data you're trying to model kind of should affect your decision. So if you're going like almost all read, no, write data views would be better, but you'd want manual indexes when you're writing more. Is that fair to say?
I guess so, yeah. Yeah, I think so because, there are, so querying indexes is slightly slower anyway than doing normal CRUD lookups because it comes off, well, it comes off disk basically. So it's not out of the cache. So I would say if you possibly can, then you should be doing normal CRUD operations. And also there's the CPU impact with running views. Every view that you write goes over every single document in the bucket. So if you've got many millions of documents in a bucket, then you can imagine that processing those JavaScript queries over millions of documents is going to have an impact on, basically on how much your cluster costs to run. So yeah.
I'll throw a scenario at you. So
Okay.
let's say you have one document, not very many updates, more reads than writes. But you've got sort of 3 different renditions of that same sort of document entity for 3 different requirements, 3 different interfaces. Does it make more sense to create 3 documents, 1 for each interface, or 1 document that caters to all?
What did you say about reads versus writes?
That it would, no writes, so it's pretty much a stale document, a static document.
then I would say very slightly that you would have the 3 copies, because although Couchbase is fast, it will be faster just to read out that one document than to refer. Yeah, yeah. I think we're out of time, so thank you very much.